right, today we're going to get into the meat of the entire object-oriented programming when we talk about Java, which is we're going to talk about writing classes. So what does it mean to write a class? How do we do that? What are the things that we need? So first of all, we talked about this a bit, but a class is a blueprint. Okay, so it's basically a roadmap for us that defines attributes and behaviors of an object. So I think I used the example of a dog. If a dog is the blueprint of the class, maybe my dog, Dobby, would be the very specific object. Okay, class can be reused and reused many different times, so we can make tons of different dogs. Okay, and this is important, and this is something that I think people have difficulty with. Class is a data type, okay? When we say it is a data type, it's much like when we say int double, those are data types. These are primitives. And then we have also class types. So we have strings. We have a dog class. Okay, any type of class that we create can be a data type. What else have we dealt with? Superhero class. These are all data types as well. So if we say an object of type dog, that would mean that dog is the actual class. Okay, when we create a class, okay, we have two components. The attributes and the behaviors. The attributes are the nouns when we look at a problem. The behaviors are the verbs or the actions. So what does our dog have? What does our dog do? Okay. And there are three components which we usually comment out. So you can see right here, remember these are single line comments. So in this case, we're making a checking account class. I called it bank account on the right. But it has data, and we want to mark out its constructors and methods or behaviors. Okay, so here we're going to do this as we go. In the bank account class, any import statements that we use are going to be at the top. We're not going to use any for right now, but then we want to comment out our data. Okay, and so we're going to say private double my balance for the balance and private string my account number. Okay. So once we have that going, these are, if we have here, like in the computer, remember this is the space, and let's say we have an account that points to an object over here. This object is going to hold a very specific value for balance, for my balance, and a very specific value for my account num. Okay, these are held, and then they control the state. So what is going on with our object? What state is our object at? Well, these pieces of our data control the state. Okay, they're also called its instance variables. The instance variable is my balance, my account number. Those are the instance variables. Their state is determined by the data stored. So let's say my balance was 100 and my account number was A579. Then these are the state of the instance variable, my balance. Okay, and it should always be declared as private. Okay. The reason is because of encapsulation. So what is this big word, encapsulation? It just means that we need to hide information. We've talked about this a bit in class, specifically with a bank account, right? When you don't want people to have control public, if you make this public, then people have control over their balance. Everybody's going to maybe set their balance to a really large amount, which would blow up our economic system. All right, so in order for us to keep it just so that the programmer has control over it, we make it private, okay? All instance variables must be declared either public or private. There is one exception. That exception is the word protected. We won't get to that for a few chapters, okay? This encapsulation is what follows what we call Parnassus principle. The developer of a software component, you only provide the user with the needed information to make use of the services, okay? Don't give them more than they need. That's basically Parnassus's principle. So, a good example is, can you use a telephone? Yes. People can use a telephone, but they don't know how to build a telephone. Same thing. Can you use the ATM, but you are not involved in any of the programming inside the ATM? This is always done on a need-to-know basis, okay? Keep as much private as possible. Generally speaking, we declare all of our data private, and we provide getter methods. So that in the case of the ATM, if we go to the ATM and somebody wants to see their balance, they're using a getter method, okay, that will give us those values, and setter methods to modify or change those values, okay? We have used some helper methods. They can be declared as private, meaning if the user is not going to use them, if they're just helping you do part of a bigger method, then just declare it as private. They don't need access to it, okay? And anything that they would need access to, you would use public for. All right, so how do we declare instance variables or data? I did this over here. The access specifier is private. The type is double for my balance and string for my account number. And then these are the variable names. Now remember, it's going to start with a lowercase, and it's camel case, so each subsequent word is going to be capitalized. The only thing that is capitalized to begin with is the class, okay? And constructors, which we'll get to later. Otherwise, everything else starts with lowercase letters. Okay. Private means, what does it mean? We talked about private, we talked about public. What does that mean? Private means that they can only, that piece of information, or specifically the word, my balance, and everything that it holds, okay, can only be accessed inside the bank account class. So if I'm coding inside the bank account class, I can use my balance. However, if I'm in the bank account client class, I cannot call my balance for any reason. I would have to use a getter method in order to access it. All right, so here are a few methods that we have. Okay, so I'm going to write public void. You know what? I'll do this as I go. So there's three methods here: deposit, withdraw, get balance. Okay, what are methods though? So remember, these instance variables give us the state of our bank account. But now our bank account, we do things with it, right? We deposit, we withdraw, we can get the balance so we can see it, all right? Methods follow a task. They are the behavior of the class, and they can take a value inside here, which is called an argument, okay, or a parameter. We're going to use the word parameter, all right? A method may return data as well, so it can spit something out. For instance, this one returns a double. Why do we want to use a method instead of doing this just line by line? Well, because we can do pieces of code on different objects over and over and over again without actually having to rewrite that specific code. We can just say, like, let's say we have two different bank accounts. We could say bank account 1.getBalance and bank account 2.getBalance instead of having to rewrite the method or the steps it would take to do that over and over and over again. So here's where I'm going to type as we go. So the syntax for declaring methods. We have three methods. I'm going to start with getBalance. So public, because I want people to be able to use it. That's the modifier. The return type is a double because I'm going to return my balance. And then I'll say getBalance. Inside here, is called the method body. So this is the modifier. This is the return type. This is the name. And if I had anything inside of here, this would be my parameters, okay? Inside is the method body. In this case, I need to spit out a double, so I want to say return double. Oh, sorry, return balance, because that's what I want to return. Let's try this again. My balance. I have to be very specific. All right. And I had two more. I had public void withdraw double amount. Now, in this case, this is going to do what I think it's going to do. It's going to subtract a certain amount of money from my account, or from my balance. So here, this is the modifier. It's public, so other people can use it. It's void because I'm not actually returning something. I'm just changing my balance. I'm updating it. Okay? Withdraw is the name, and I need a parameter. I can call it amount. This is the name of my parameter. Oh. I can call it whatever I want. In this case, I decided to use amount. But I need to be specific about what the type is. Okay? So, here, what am I doing? I'm saying I need a double, and I'm going to subtract that much off. Since, if you noticed up here before I had this return statement, it was red because I needed to return something. But because this is void, I don't get anything red. I don't get any errors because I've done what I wanted to do. Now, let's write one for deposit. And now I'm going to add to my balance. Now you may be thinking, why can't I use amount twice? Well, we're going to talk about this in a little bit, but basically, this value amount is only alive inside this method where it's declared. Same thing for this one. So these are actually two different amounts. They're seen by the computer as two different things. Okay. Methods can return values, so that means it can spit something out. In this case, this spits out a double. You want to be careful, though, because as soon as you have a return statement right here, you pop out of the method immediately, okay? Now, in this case, you can also not return anything, and if you don't want to return anything, you make the return type void. So here is a return statement. If I wanted to spit out of a method that was void, so it was just updating something, let's say I had an if statement, and if something happened, I wanted to stop my method, then I could just write return here, like that. And that would immediately spit me out without returning anything. Now, in this case, we don't need it, so I'm going to take it out, but I just wanted to put it there to show you. All right. So we have two types of methods that focus on the state of instance variables. These are accessor methods, or what we call getter methods, and mutator or setter methods. Okay, so I like to use the terms getter or setter. An accessor method is literally just returning the state of the variable. So I'm going to write getter method here because this is just returning what balance is. And a setter method is actually setting the state of the variable. So it's updating it. So I'm going to call this setter method and a setter method. I'm also going to use the word accessor and mutator because that is how it's described in your book. And in that way, you'll follow what I'm saying and also what the book is saying. So, accessor methods are going to have a return type. It's going to be whatever the instance variable's type is because you're just spitting that out. So, double, it matches. Let's say I wanted another one for the account number. Getter accessor method. And it's always a good idea to comment this out, like what type of method it is. So, I'm going to say public string because I'm spitting out a string. Get my account number. And then I don't need, generally, getter methods, you don't need any parameters because you're just spitting out what's there, the instance variable. And that's it. You just spit it out, return it. Okay. A mutator method, they usually have type void. That is because you are just updating it. Okay. So here we have on the right, I wrote out exactly what is here on the left. I just used my balance instead of balance because my balance is the name of our instance variable at the top. So parameters, we can pass information into a program. We'd like to pass them in specifically in the withdraw and the deposit method. You can see it's useful because we want to take out a certain amount or put in a certain amount. So you will hear them called sometimes as value or formal parameters. Okay. When it is in this class, so it's existing as kind of a placeholder for when we put the actual amount in, it's called a value parameter. When it takes an actual amount inside the client class, or when we give it a concrete amount, like in the case on the left where it says double paycheck becomes 200. Okay, so this is an actual concrete value of 200. It's a formal parameter. So in the client class, we'll get a lot of formal parameters. And it doesn't matter that it's paycheck or 200. Either would be considered a formal parameter. All right. So remember I said before, I wrote amount here and amount here, but the computer knew the difference. This is why. Value parameters, or the parameters here, are specifically what is called a local variable. So it's really important that you pay attention to this word local because I'm going to be using it. Okay? What does local mean? It means that it only has a life or a scope inside a certain area. In this case, amount or any sort of value parameter only is alive as long as I'm in the withdraw method. Once I'm outside of the withdraw method, this value amount is dead. Same thing here. This value amount is only alive when I'm inside the deposit method or when I'm working inside the deposit method. Okay? If I try to call it out here, it's red because there's an error. It doesn't know that it has no more life. It's not living outside of here. Okay? The other thing I wanted to say is that's why I can use that word amount, because amount here is different from the amount here. They're two different amounts. The computer sees them differently. Okay? The other thing that's important is that it's receiving a copy of whatever this is. So let's say the amount is, I don't know, 200. In this last case, paycheck. So the amount it was of paycheck was 200. No matter what happens inside here, unless I reset it outside of it, it does not change. Okay? So the variable paycheck remains unchanged within the client class. It still holds that value 200. That's very, very important. Now, that's the case with strings also because they're immutable. The only caveat to that is if I have an object, which we will put objects in here, okay, as parameters. If I have an object, it is referring to its reference, okay? So let's say I had a method, I'll just call it my method. That takes in a dog spot. Okay. And then maybe it does something to spot. I don't know what it does. Maybe it says spot dot update age. Okay. We'll say that this is void. And if, for some reason, if you run into something that doesn't have a modifier in front of it, we like to put them, but if it's not there, we can assume that it's public. That's the default. All right, so if I called this method, it is dealing with the reference for spot. So if this is here and this, I made this a little small. So let's say this is here in the computer, spot, and spot points to somewhere where it's like the address is @dog572. What's getting passed in here is @dog572. So the age of the dog is actually updated. So let's say that his age was, I don't know. No, that's really old for a dog. Let's say his age was 2. There we go. If I update the age for him to be 3, let's pretend, the actual dog itself is changed. The information, I should say that, I should rephrase that. The information that the dog holds is changed. This reference is not changed, but the information for the dog is changed. Now, when I'm talking about primitives or strings, the argument is not changed, okay? This is a very, very, very specific point that's important for primitives and strings. As arguments, not changed. If an object is put in here, then its information can be changed. Its reference will not be changed, but its information inside of it can be changed. Okay? And just to be clear, when I'm saying that the object, what the state of the object is changed, the reference, which was actually what is plugged in as the argument, that still is unchanged. So, a value parameter, it can be modified within the method, but it doesn't change the value of the argument. So, paycheck would still be 200. In this case, dog spot would still be @dog572. Its reference still is not changed. Value parameters are one way. So information goes into a function, but information is not passed, but no information is passed back through the value parameter. So we're not getting information out. The only time that would happen is, actually that wouldn't happen at all. We can resave over a specific amount, but in general, no. See, a single value can be passed back using the return statement, which is what I was just talking about, but the formal parameters are not changed. All right. So, we also need to talk about, all right, well, what else about value parameters do we need? Okay, well, they have types, and they have names, in this case, int a double x, okay? When we put things in, they have to be the appropriate type. So, is this okay? In the client class, we have 2 and 3. So this is 2 and this is 3. This is an int. And 3 can be treated as a double because we can pour an int into a double. So this one would be okay. Even though this is an int, it'll see this as 3.0. That works. Int double. Uh-oh. This one goes double int. Is this going to work? No. Okay. What about int double? Int double? Yes. This one will work as well. So remember, it is important that we have the correct type in the correct order. And also, can ints be poured into doubles? Yes. Now, the only difference is if I had used the integer class and the double class, then these need to be specific. So if you have the double class, you need an actual double. So you need like 3.0. Okay? Well, we have what's called the signature of a method. I need for you all to be familiar with this term, because when we talk about signatures of methods, we talk about them when we talk about overloaded methods and overriding methods, which are both important pieces to the conversation when we talk about Java. So when we have a signature of a method, we have three pieces: the name, how many parameters it takes, and the type of each parameter. It does not care about the return type. It does not care about the modifier. It does not care about the names of the parameters. Very specifically, these are the things it cares about: the name and each type and order of the parameter. This is because when we go into the computer, what does the computer look for? It looks for the name, and it looks for the number of parameters and the order that they're in. Okay, it doesn't care about anything else. That's how it decides which one it's going to use. So we've talked about overloaded methods. So Java allows for two different methods in the same class to have the same name if their signatures are different. So the compiler chooses the correct method based on the number and types of parameters. So let's say we wanted to make another, we'll call it setter mutator method. Another method deposit. Now, this one we don't really need to do, but it's a good way to show us overloaded methods. So I can call it int amount. And I'll say my balance plus equals amount. Okay? What's going on here? Again, it doesn't care about the name because the names are the same, but the types of parameters are different. This is okay. This is called an overloaded method. If I put in my tester class, let's create a bank account object. Oh, I don't have I'll do that at the end. I don't have a constructor yet. So let's pretend that I put in a specific amount. I put in an integer, it's going to look for the one with an integer. If I put in a double, it's going to look for the one with the double. All right. So